Space architecture is a field of architecture that focuses on designing and planning for human habitation and activity in space. It encompasses the design of spacecraft, habitats, and other structures that are intended to support human exploration, research, and commercial activities in space. Space architecture is a multidisciplinary field that involves expertise in areas such as aerospace engineering, materials science, robotics, psychology, and human physiology. The design of space architecture must take into account the unique challenges posed by the space environment, including microgravity, radiation, temperature extremes, and isolation. The design of space architecture must also consider the human factors involved in living and working in space, such as the need for psychological and social support, as well as physical health and safety considerations. The layout and functionality of space habitats and structures must provide a comfortable and safe living and working environment for astronauts and other space occupants. Space architecture is also closely tied to space exploration and the development of new technologies and capabilities for space travel and habitation. The design of space habitats and other structures must take into account the availability of resources on celestial bodies, such as the Moon and Mars, and the need for sustainable and self-sufficient systems for long-term habitation. As humanity looks towards the future of space exploration and habitation, space architecture will continue to play a critical role in designing and planning for human activity and settlement in space. Can we build on Mars? Mars is often considered as the next frontier for human exploration and colonization. But can we build on Mars? In this video, we will explore the challenges and possibilities of building on the Red Planet. The first challenge we face is the harsh environment. Mars has a thin atmosphere, extreme temperatures, and high levels of radiation. These conditions make it difficult for human survival, let alone building structures. The second challenge is building structures that can withstand the harsh Martian environment. The structures must be able to maintain a stable temperature, shield occupants from radiation, and provide an adequate supply of oxygen. The third challenge is obtaining the necessary materials and resources for building. Unlike Earth, Mars does not have abundant natural resources that can be easily exploited. We will have to rely on technologies like 3D printing and resource utilization to extract and process the available resources on the planet. To overcome these challenges, we will need to develop new technologies and innovations. For example, inflatable habitats that can be transported to Mars and then inflated on site could provide a lightweight and cost-effective solution for building structures. Collaboration and international efforts will also be crucial for building on Mars. NASA and other space agencies have already initiated several programs and missions to explore Mars and lay the groundwork for human missions. Private companies like SpaceX and Blue Origin are also investing in space technologies that could enable human settlement on Mars. Despite the challenges, there are many benefits of building on Mars. Building on Mars could pave the way for human settlement and create new opportunities for scientific research and exploration. It could also provide a backup plan for humanity in case of a catastrophic event on Earth. Looking into the future, building on Mars will likely become a reality in the coming decades. With the advancement of technology and the increasing interest in space exploration, we may see the first human settlement on Mars within our lifetime. Building on Mars is a daunting challenge, but with the right technologies, innovations, and collaborations, it is not impossible. The possibilities of building on Mars are exciting, and could change the course of human history. Becoming a Type 1 civilization on Mars, as defined by the Kardashev scale, would require harnessing and utilizing the full energy output of the planet. This would require significant advancements in technology and infrastructure, as well as a significant human presence on the planet. Here are some steps that could be taken to achieve this goal. Establish a permanent human presence on Mars. The first step towards becoming a Type 1 civilization on Mars is to establish a permanent human presence on the planet. This would require significant investment in space exploration technology, such as reusable spacecraft and habitats capable of supporting human life. Develop Mars' natural resources. To become a Type 1 civilization, we need to utilize the full energy output of Mars. This can be achieved by harnessing the planet's natural resources, such as its wind, solar, and geothermal energy. Mining and extracting resources such as water, minerals, and metals from the planet could also provide valuable resources for human use. Build large-scale infrastructure. To utilize Mars' energy resources, we need to build large-scale infrastructure, such as solar power plants and wind turbines. This would require significant investment in advanced engineering and manufacturing technology, as well as the development of new materials and construction techniques. Develop a sustainable economy. A sustainable economy on Mars would require the development of new industries, such as agriculture, manufacturing, and energy production. This would also require significant investment in education and training programs to support the development of skilled workers and researchers. Terraform the planet. Ultimately, becoming a Type 1 civilization on Mars may require terraforming the planet, which involves transforming its atmosphere, temperature, and other environmental conditions to make it more hospitable to human life. This would be a significant technological and environmental challenge, but could ultimately allow us to harness even more of the planet's energy resources. Becoming a Type 1 civilization on Mars is a long-term goal that would require significant investment in technology, infrastructure, and human resources. However, it is an achievable goal with the right combination of vision, planning, and investment. Let's take a look at the history of our fascination with Mars and the possibility of life on the Red Planet. 1877. Our story begins in 1877 when Italian astronomer Giovanni Schiaparelli observed surface features on Mars and named them canali, meaning channels in Italian. However, the term was mistranslated into English as canals, leading to speculation about the possibility of intelligent life on Mars. 1898. The concept of Martians was further popularized in H. G. Wells' science fiction novel The War of the Worlds, depicting an invasion of Earth by Martians. 1965. Fast forward to 1965 when the Mariner 4 spacecraft became the first spacecraft to fly by Mars and return close-up images of the planet's surface. These images provided a wealth of information on the planet's geology and led to further exploration of Mars. 1976, the Viking 1 and 2 spacecraft landed on Mars in 1976 and conducted experiments to search for signs of life. Although no conclusive evidence of life was found, these experiments provided valuable data on the planet's geology and potential for habitability. 1996. In 1996, the ALH 84001 meteorite, which originated from Mars, was discovered to contain possible evidence of fossilized bacteria. This discovery fueled speculation about the possibility of past or present life on Mars. 2004, the Mars exploration rovers, Spirit and Opportunity, landed on Mars in 2004 and explored the planet's surface, providing new insights into its geology and potential for habitability. 2012, The Curiosity rover landed on Mars in 2012 and began conducting experiments to assess the planet's habitability and search for signs of past or present life. 2015 In 2015, the movie The Martian, based on the novel by Andy Weir, was released. The story follows an astronaut who is stranded on Mars and must use his scientific knowledge and ingenuity to survive. 2020 Finally, in 2020, the Mars 2020 mission, including the Perseverance rover and Ingenuity helicopter, landed on Mars to search for signs of past microbial life, collect rock and soil samples for return to Earth, and test technologies for future human missions. There are several places on Earth that have similar geological features to Mars and are often used as analogues for studying the Martian environment. Here are some examples. Atacama Desert, Chile. The Atacama Desert is one of the driest places on Earth and has a similar climate and geology to parts of Mars. The desert has vast expanses of red and orange rocks, sand dunes, and dry riverbeds that are reminiscent of the Martian landscape. Wadi Rum, Jordan. Wadi Rum is a desert valley in Jordan that has been used as a filming location for several movies set on Mars, including The Martian. The valley's red sandstone cliffs, canyons, and rock formations have a striking resemblance to the Martian landscape. Moab, Utah, USA. Moab is a region in Utah that is home to several national parks, including Arches and Canyonlands, that feature unique rock formations and desert landscapes that are similar to those found on Mars. Devon Island, Canada. Devon Island is located in the Canadian Arctic and has a polar desert climate that makes it a useful analogue for the Martian environment. The island has vast expanses of barren rock and permafrost that closely resemble the Martian landscape. Valle de la Luna, Argentina. Valle de la Luna, or Moon Valley, is a desert region in Argentina that has a rugged and barren landscape that is similar to the surface of Mars. The area features jagged rock formations, sand dunes, and dry riverbeds that resemble the Martian terrain. These places are often used as analogues for studying the Martian environment and testing technologies and equipment for future Mars missions. Hope you found this video interesting. There is really so much potential with space architecture which could potentially turn into a reality for us in the future. Don't forget to like and subscribe. Leave a comment under the video and I will respond to you if you have subscribed, and I will see you in the next video.